Given a function f of x, we can tell if the function is continuous at a specific point if we can follow the three conditions. The first condition for the function f of x to be continuous at a specific x value, in this case we're going to say x equals a, is that f of a exists. So whatever the x value is, if you plug that into the function, there's an actual value. The second condition is that the limit as x approaches a of f of x exists. Now, something very important to know on this is that means the limit as x approaches a from the left of f of x has to equal the limit as x approaches a from the right of f of x. So those two conditions must be true. And the last condition is that the limit as x approaches a of f of x must be equal to f of a. So let's take a look at a graph and we'll test the values and test these three conditions to see if f of x is continuous at the specific values. All right, so here's my function. This whole graph is f of x. I am going to determine well, we can look at this graph first of all, and it is obviously not continuous at some specific values. So let's start with one where it would be continuous. So let's determine if f of x is continuous at x equals 1. Negative 1. Let's do negative 1. All right. So the first condition is, does f of negative 1 exist? And here is f of negative 1. It is equal to 0. So, yes, the first condition checks out. My second condition is, does the limit exist? So, the limit as x approaches negative 1 from the left is equal to 0. And the limit as x approaches negative 1 from the right is equal to 0, so we're going to go from the right direction. So that means that, yes, my limit of f of x as x approaches negative 1 is equal to 0. And then the third condition is, since this and this are equal to each other, the function is continuous at x equals negative 1 because all three conditions are true. All right, let's test the three conditions for continuity at x equals 2. So the first condition is that, does f of 2, what does f of 2 equal to? All right, so here's f of 2 right here. So that means that f of 2 is equal to 2. All right, perfect. The second condition is, what is the limit as x approaches 2 of the function? So the limit from the left is approaching 1, and the limit from the right is approaching 1. So since the limit from the left is equal to the limit from the right, and that value was 1, the limit is equal to 1. Now the third condition here is that this f of 2 must be equal to the limit at 2, but that is 1, and those are not equal to each other. So the third condition is what makes this not continuous. So we say the function is not continuous at x equals 2 because condition 3 is not met. Let's look at one more. Let's look at when x equals, let's do 6. Because when x equals 4 and x equals 6, it's kind of the same idea. The only difference with 4 is the limit is not going to exist. So the first condition will actually not be met at x equals 6. because there is an asymptote, you are never going to have a value. So the function at x equals 6 does not exist or is undefined. The limit at x equals 6, the limit from the left approaches infinity, and the limit at the right approaches infinity. So that means the limit as x approaches 6 of our function is equal to infinity. However, the third condition here is that the does not exist has to equal infinity. We'll just write it like this. That is definitely not okay. So our function is not continuous at x equals 6. So our final conclusion at x equals 6 is that the function is not continuous at x equals 6 because